Hey everyone, in this session we're going to discuss NumPy, the Python NumPy module. As you can see, I'm on the numpy.org website, and you can see the latest version is 1.24.2, and you can get the entire documentation using numpy.org website, or you can just go for general purpose kind of documentation for Python. You can go to docs.python.org, and I'm going to show you also how to get this information from inside Interpreter. In this session, we're going to discuss the entire NumPy module here. Let me just go through a slideshow here, what I have for you. So we're going to discuss NumPy module, and this is tutorial number 1. Basically, it's an introduction level, and we're going to introduce you the Python NumPy module, and we're going to tell you what it is. Again, my name is Wahidullah Lutfi, or Wahid Lutfi for short. I'm going to be showing you what is NumPy module, how to install NumPy module if you don't have it already installed, how to import NumPy module, how to get a directory list of NumPy methods and objects, how to get help on a NumPy module, and then create a number of n-dimension array objects, which is a multi-dimension array object using NumPy methods, and how to manipulate NumPy objects and methods or attributes. Use the predefined NumPy methods that is already coming with NumPy. I would create it, how to manipulate it. For more depth knowledge of NumPy, we're going to just have more videos, but at the same time, until I have those subsequent video number 2, 3, so on, you need to just also visit the docs.python.org for any general purpose documentation on Python, as well as the specific of NumPy. Visit https://numpy.org, which I just showed you. That's the website for documentation of NumPy and all the sub modules that are used in there. You can get it, so you're welcome to do it. And at the same time, I'm going to show you through the interpreter how to get help on NumPy modules, attributes, objects, and the U functions. So what is NumPy? First, let's discuss what NumPy provides us. What NumPy provides us is an array type of objects of arbitrary homogeneous items. What does that mean is not like the Python list structure. Array type of objects of arbitrary homogeneous of item, meaning that the data type of the array is the same, whether it's float, it's all of them are float. If it's integer or string, it's all of them are string. Arbitrary means it's your preferences that you can just specify a set of like odd numbers or set of even numbers. Whatever you want in the range of the functions, you can just do a user-defined arbitrary options. But homogeneous meaning that the element of the array are all of same type, which is like if they're integer, they're all integer. If they're float, they're all float. Like C language, like programming language of Java and other ones, but not like Python list. Python list, you can have inside a list, you can have multiple elements of different data type. And so inside a list, you can have a string item, and you can have an integer item, a false, a Boolean expression of false or true values, or any data type of that is another list of inside a list. But with an array, everything is homogeneous, which is makes it very fast. And because the data, the memory, everything is stored in contiguous memory, and then also it's written in C. NumPy is written purely in C, like regular expression is written in C. A number of Python modules are written in C, not in Python itself, but it is written in C. So for this kind of purpose, because the items are homogeneous, there is no overhead of keeping these extra information stored in memory and then manipulating them. So it's much faster, and it's also contiguous memory, as I mentioned. And it's also does a lot of fast mathematical operation over arrays. The same reasons that since the data is contiguous, and then it's also homogeneous data, and is stored on memory with the same data type, and also a contiguous location of memory, and there's no overhead involved like less. This is much faster in terms of operations, doing mathematical computations. And also it does a linear algebra, Fourier transformation, random number generation. So these kind of options that makes kind of a Python programming language, and especially NumPy, a very enhanced kind of style of coding, that it allows you to do any number of data science kind of modules or programs, or applications, and machine learning, all kind of arithmetic and then linear algebra formulas that are there, especially for Fourier transformation and random number generation, aside from linear algebra as well. So let's talk about how to install NumPy. If you don't have a Python installed, obviously you have to install Python. But once you have Python installed, the package pep or pep3 also comes with Python, that you can also just check for a specific module like NumPy. So pep also has commands like list, show, and other ones that you can see what is the name of the package. In this case, a pep install NumPy will install the NumPy if it's not already installed. But if the requirement is met, it will tell you that NumPy is already installed. So pep space install, name of the package that would install the Python. And how to import NumPy. Once you install it, obviously you install it to use it. In order to use it, you have to import it, which means loading the module, and then the libraries and all the module that are inside. NumPy also has the OS module, the matplotlib, and then the SAS modules, and a number of other multi modules inside NumPy that runs in. So you can just do import NumPy as NP. NP is the alias name that all the developers kind of understand as the abbreviation for NumPy. So that's a standard. And just do import space NumPy as NP, and then now NP dot object name or dot method name or dot attributes will be available for you. So this is how you load the NumPy module inside your module. How to import NumPy? You just type in import NumPy as NP. To get a directory list of NumPy methods and objects, you do a dir on NP. So, but you have to import it first. If you don't import it, it's not a part of the standard Python packages. So once you install it, then it doesn't come as a standard. So you have to install it first. And once you install it, then you just say import NumPy as NP. Now you can do a dir on the NP module, and then you will get a directory list of all the methods and attributes that are associated with NP module, or NP alias in this case. Get a directory list of NumPy methods. In order to get on a specific method, you have to do, again, import NumPy as NP first, then followed by the dir on the NP dot method. In this case, method is just a kind of like a template kind of name, but I'm just giving you example of np.sort, np.arrange, np.empty, np.0, and so on. All of those methods are part of the Python NP or NumPy module. Once you want to get specific to the sort method of NumPy, you do a dir on it. If you want to get a sort on array, then you do a dir on NP of dot array and so on. And in this case, sort and arrange is shown as an example. Get help on NumPy modules. How to get help? Very easy. First, you load the NumPy module. So you say import NumPy as NP. And then once you do that one, and then you have to do print help on NP. So print and help on NP. This is the native help of Python. So you can get information on the NumPy module. And in this case, the alias NP is going to, if you do a type on it, NP shows that this is a class, a NumPy library, so or module, and then you just get help on it using the help method of Python. Get help on NumPy methods. If you want a specific method, then you have to do print help. First, you have to import NumPy as NP, like I mentioned before. Once the NP alias is defined, then you just say print help np.sort, print help np.array, print help np.0, print help np. Let's say arrange, or whatever method that you want to do. You just give those a name, and then np dot, and that name will be defined. You can also get help on NumPy keywords. To get a keywords, you search for it, like almost like a query on a specific keywords. So you say first import NumPy as NP, then you get print help np.look for. The method is called look for, and then the string that you're looking for is the keyword that you're looking for. In this case, I'm giving you an example of print help np.look for, and then the sort function. If you want to do the swap function, you just have to put the word swap. If you want to do like copy function, you do that copy. Array function, you do array. So that's how np.look for a specific keyword works. Get info on NumPy objects. Import a NumPy as NP first, and then you say np.info object. So earlier we were showing you the help on NP itself, but now on certain objects, once you define an array as to be an object, then you can get this info on it. And the info, the Python native help does not support that. You just have to go np.info method and then give the object name. For example, if you create an array of A, then you have to do np.info, and then instead of the object, you put the A here, and it will give you all the dimension and all the details there. So this is written purely in C. It's called U functions. U functions are implemented in C, not in Python, because of the speed. And then the native Python help does not know how to view their help, but the np.info method does. And what does that mean is that earlier I mentioned that this np.info on array. So let me just show you an example of how you do it. So first you do import a NumPy as NP to get info on the object A, which is the array that we create, np.0, and then we zeros, and then we create 5 elements of with elements zeros, 5 of them, and then this is an array. And then when you do np.info A, it's basically giving you all the details of that one. I'm going to show you that one also as an example at the lab part. So summary of what we learned today. We already covered how to install NumPy, how to import it, how to get directory listing, how to get help on modules, and how to manipulate them, and so on. All of that one is going to be shown now at the lab time as well, but more to cover. We're not done with NumPy. This was just barely a tutorial number 1, which was an introduction to NumPy. NumPy is so huge, which I'm gonna show you just from the directory listing how huge it is, and what other modules that are coming inside NumPy. So it is barely hard to just if anybody claim that they can teach you Python within an hour or half an hour NumPy module. It is impossible. But you are getting the general overview of how to install it, how to load it, how to do a directory listing, how to get help on it, where to look for more information if you have to go to the website. Then the rest of them, the method and the object that you use, basically almost like an API call. The more you work with it, the more faster you get at manipulating those data. So it is almost like a calculus or math. The more you work with it, the more easier it becomes. If you don't work on it, obviously, it is not that intuitive. So let's just get started with the example of some of the things that I mentioned here. First, I'm on a Windows machine, CMD. You can see I'm on a Windows 10 machine here. So I'm going to clear my screen, and then I'm going to say Python -- version to just show what version of Python I'm running, and then pep -- version. So pep 3 or pep has to be installed in order to get the NumPy. In order for me to know where NumPy is installed or not, I could do a pep list and then find a string /i, look for NumPy. This is on Windows. You can do this to just list them and then see if that version 1.23.1 is installed already. If I just want to install it, if it was not installed, I would do pep install and then followed by NumPy. That is the name. And so now, since I have already installed it, it says requirement already satisfied. So I don't have to install it. And then it shows you the package directory structure where side packages include this NumPy module. So now it is installed. I need to load it. In order to load it, I need to get inside the Python interpreter by just typing Python 3, and I do a directory listing. As I mentioned, it is not part of the standard, so it will not show here. So let me just do import os.system, os module and os.system. I'm going to clear my screen here. Let me just do it quickly here. Exit out of here, clear screen. So Python 3, I meant to type in import OS. Whenever you do os.system, you have to write the function clear screen command for that operating system, which in this case is Windows. So it will clear screen. Now, if I say dir of these objects, notice that OS is loaded because I just load that one. Similarly, NumPy is not loaded. So if I type in help on NumPy at this time, NumPy is not going to show. But if I say help on OS module, it's going to show. That means OS is just part of the standard library that I didn't have to install it, but it is installed already. So clear screen, Python 3, and then I'm going to say dir. Notice that this time OS is not loaded and NumPy is not loaded either. So I'm going to say import NumPy as NP. In order to use NumPy, you have to import it first. Now you do a dir, you can see NumPy is already this. So if I say type of this NP, you can see it's a module. It's a module. So if I say dir of NP, show me the dir, you can see that there's a lot of methods associated with it. And then we're going to discuss these ones in multiple sessions. So bear with me and just depending on how much time I have, from time to time, I will just make one video and then post it as tutorial 1, tutorial 2, and so on. This one is tutorial 1, so we just are barely hitting the surface of NumPy. So we already know, let me just show you exactly what in this video. You are first doing a pip install NumPy. If it is not installed, you just do a pip install NumPy and it will just go through installation. But since it's already met, you could just go to Python 3 and then just say import NumPy as NP. Now, dir of NumPy, it will tell you all the functions and methods that are there, and then help on NP will just print out the help on NumPy module. And as you can see that it says arbitrary object of homogeneous item, which is written in C language. The data type are the same. So you're defining these ones, and it's a contiguous area of memory. It's fast, and then does a lot of mathematical computation. So it's great for data science and all that things. And then as well as it shows here on the help for the U functions. U functions are implemented in C, like I told you. So some of the information I just kind of like took it from the documentation of Python. So I'm not making my own kind of like claims. These are facts that are just, you have to read it and understand them, and then just work with it. So some of the details are here. So if I just want to know, and let me just do import. So you can also do, as you can see here, os.numpy.os is also there. So if you want to go specific to what other methods are inside this, like the directory of numpy.sys is another module. If I want to say type or numpy.sys, you can see that's also a module. And so is OS there. So I could just say, since NumPy is imported, I can do a directory of numpy.os.system. So you can see that that method, that the system method is defined inside the OS, and OS module is loaded inside NumPy. So I can even do a numpy.os.system and do the same thing here, say clear screen. So that would just also, I don't have to load the OS module here. Similarly, if I just say directory of numpy.sys, you can see that this is a directory of np.sys. You can see that that is also having this. So I could say, like, for example, the Python version, I could say print np.sys.version info. So this would give me the version information of the np. And I need another bracket here. So let me just do first os np.os.system, and then run the clear screen command. So we have a this command that I meant to write, I just missed something. np.sys.os version info, and then right here you just have to close it like that. So that is np module that has the sys module inside of it, and we're using the attribute version information. If I want to just get the version information, I get the version information. So there's a lot of similar things, like, for example, print np.os.get current working directory. Let's say that's a method that is there. You can see that I'm on this. And get login ID, for example, login ID. Maybe it is login ID. Let me see, check. Get a login. So if you forgot the name as get login ID or get login, you can just try get login, and that's login and not login ID. But if you forgot it, you could just say print np.os and then just get a directory of listing of this dir of np.os just by itself. This will just print the directory listing, and then most likely it's on this list here. So I was saying login ID, and if you don't see it here, you can also do something like this. You can say for item and dir of np.os if you know that it has something like git, a start git, whether it's git directory or git current working directory or git login, you start with this one, n item, then print it. So you could get like help on this one, print item. And this one will just say, oh, the name was git login, not git login ID. So if you want to say get process, pattern process ID, get process ID, and get environment, get current working directory, and B, and again, current working directory itself. So all of that informations are specific to that one. The reason I'm showing you that NumPy is big, you can even have modules inside of it. And we're going to do some like matplotlib stuff and all those other things that are good for graphic and mathematical computation. We were going to do those ones as well. So at this time, I'm going to show you a couple of other things for how to get help. So let's say first, let's say np.os and then .system, clear my screen, and then come back here, say help on np. Remember, help on np give me everything on NumPy, but if I want to get like sort methods, I could say help np.sort, and then that would just give me np.sort. Remember the u function, if you see on the top, the u function that is listed there, then that means you can get info on it. But if it is not listed, then you cannot. So that is here. So if I just say np.info and then np.sort, then it's going to give me the sort functions that are specific to using that method. So I can see the entire things here. And then you can see if you want to sort it by access or anything, it tells you the entire detail here. You can also get help, like help on np.sort, like this. So this will just tell you that this is a sort method that has this name of the array, and then the access, which is a -1 or 1 or 0, depending where you started it. 0 would be first row and 1 would be first column, and so on. And then all these details are just here. You can just do it. And then the access is, and every function, you can just pass it on as argument. So you see, this is a 0 sort along the first axis. And so you can sort it and everything. But at the same time, if you want to know a little bit more detail of the u function, the info, you can just define a clear thing here, and then say a is equal, which I'm going to create a array a, and then I'm going to just say np dot let's say zeros, and then I'm going to just say 5. And then now a is already 5 of these, one with floating point number zeros. And then since I have it, and I could say a dot shape, you can see the shape of it. A dot size, I can get the size of it. But if I just say help on a, Remember I said that Python native does not know how to get help on it. It tells me the number of dimension, all these details are a little bit too much kind of like functions that you can perform and so on. So this is different than doing something like np.info and then a. As you can see here, this is a method in p.info was specifically written in C for you functions to just take this object name, and the object name in this case is array A. So now it says class in the dimension array, and then shape is 5 because it has 5 elements, and then stride is 8, item size is 8, aligned is true, contiguous is true. Contiguous true meaning it is homogeneous, the data type is the same. So if I create a floating point, it is all the same data type and memory that is stored in contiguous location. So it's a much faster computation. Fortran through data pointers and border and so on. And then notice that it is by default is float 64. That data type that you can also create a.d type, you can get the data type is 64. So you can get that one also. Some of them are specifically with those attributes. So dir of a, you can see that all the things that you can do with it. And I just did like a.d type and a.size or a. Like data type, we just checked it. So a lot of these functions, we will go through those ones. And then if you want to get a specific help on it, you can say also, for example, np.info, and then you don't have to say just a, you can say a.copy, for example, how to copy that one. And it shows you that help on it with examples, and it right here, the U functions, that is just providing you the details of it. You can see a lot of more information here. And p.info a copy, and it says that return a copy of the array, and then the orders, all the details are given here with specific information that you can just get. Okay, so this was a good example with the info, and then let's just look for the np.look for. So if I just say look for, and then I'm going to say sort function. You can see that the sort details, all of them are there. Similarly, if you could say look for a keyword like swap, anything that you're interested in, you just get all the functions that are related to swap, and then look for data type, D type. So it is just specific to those ones that you're looking for reference. So look for is the keyword that you match, and then info is the help on and the actual size. And then I believe I covered everything that are here because we wanted to install it, which we did, import NumPy, load it, and then get the directory listing, help on NumPy module, create the in dimension. The in dimension, we just created a dimension there. And there's going to be more specific examples with how to manipulate them, how to do it on video number 2 and so on. So just look for those ones. And thanks for your time. Thanks for watching. And then I hope you learned something from it. And we're not done yet. We're going to have more videos. So please make sure that you subscribe at our channels. If you like to just me including, if you want me to include something for you on NumPy or a specific question you have, please just make a comment on the video. And thanks for watching. Take care.